Okay, so let's talk about the memory wall.
Mhm.
It's probably the single biggest bottleneck in AI right now.
Yeah.
We are burning through just massive, expensive GPU compute.
Just to get a model to remember a static fact.
Exactly. It's like using a Ferrari to deliver the mail.
It really is.
Mm.
I mean, you ask an LLM, what's the capital of France? And it has to spin up billions of parameters, do all this crazy math.
Just to spit out Paris. It seems so inefficient.
Well, that inefficiency is exactly what we're tackling in this deep dive. We've got two papers that really flip the script on AI memory. We're looking at DeepSeek's Engram and MemRL.
And the mission here really is comparison. Because based on the reading, this isn't just about better memory. It feels more like a split in philosophy.
How so?
Well, Engram seems to be solving the storage problem, how to fit the whole internet in a box, But MemRL is solving the learning problem, how to adapt on the fly.
That's a great way to put it. It's the Library of Congress versus your personal diary. Engram is a huge static library.
So let's unpack the library first. DeepSeek Engram. The paper brings up this idea they call the reasoning paradox.
And this is the key insight. It's actually pretty counterintuitive. It turns out, if you stop forcing the model's neural network to memorize every single fact, and you just offload that data to a simple lookup table, the model's reasoning scores, they actually go up.
Because the network isn't being distracted by all that rote memorization, right?
Essentially.
Yeah.
All that compute is freed up for actual logic. But the way they do it is what's wild. They're bringing back engrams.
Wait, engrams. That's prehistoric tech in AI years. That's pre-deep learning.
It is. But they've modernized it with something called multi-head hashing. So instead of heavy compute to predict the next token, the model just peeks at this giant engram table to see what usually comes next.
So it's an O1 lookup. It's basically instant.
Instant. And the hardware side of this is, it's a game changer.
They're not storing this on the GPU, are they?
Not a chance. Way too expensive. They're dumping these huge tables onto CPU RAM.
Which is dirt cheap, and you can have tons of it compared to HBM.
Exactly. And they use asynchronous prefetching to stream the data over so fast the model doesn't even know it's waiting for it. They found this U-shaped scaling law.
Yeah.
The sweet spot is like 20-25% of your system is this memory, and the other 75% is pure compute.
So Engram is the massive static cortex. It knows facts, but it doesn't really learn. That brings us to MemRL.
The diary. Yeah, this tackles the stability plasticity dilemma.
The classic problem. You teach a pre-trained model something new, and it just overwrites old knowledge.
Catastrophic forgetting, right? MemRL gets around that by just freezing the model's weights. It uses an external memory buffer instead. But, and this is the key difference from standard RAG, it doesn't retrieve based on what's relevant.
It looks for what provides utility. This is the critic thing, right? The IEQ triplet.
Yes, intent, experience, and utility. See, a normal retrieval system is semantic. If you ask for a coding solution, it might pull up a doc that just talks about the error because the words match.
But doesn't actually solve it?
Exactly. MemRL tracks the outcome. It judges the value. If a memory leads to, say, a failed code compilation,
And downvotes it.
it literally lowers the Q value, the utility score, for that memory. It creates a negative memory. So next time, it knows not to try that strategy. It's learning from failure in real time.
So if we put these two papers together, synthesize them.
Yeah.
We're looking at a kind of dual process brain.
It's a surprisingly good analogy for human cognition.
Yeah.
You've got Engram as the cortex,
Yeah.
that stable, crystallized knowledge you can access instantly.
And MemRL is the hippocampus handling the new dynamic episodic stuff. What just happened today.
And the sources even hint at a future where they connect. You'd use MemRL during the day to learn from immediate experience.
And then maybe during some kind of sleep cycle, you distill the really useful memories into Enneagram's static tables.
Consolidation, yeah. It's a huge shift. We're moving away from this bigger is better brute force approach.
And moving towards something more sparse and adaptive, modular systems that learn a bit more like we do. Which leaves us with a final kind of provocative thought to wrap up. If MemRL lets an AI selectively remember what works and, more importantly, suppress what doesn't based on its own failures, are we crossing a line from models that just process data to agents that actually experience it?
That is the question, isn't it?
Something to think about. Thanks for listening to this deep dive.
See you next time.